All right, so let's look at the last part of the data types, and of course, let's get a clear distinction between the data that is supposed to be used for supervised learning as against the one that is to be used for answering. So I've managed to put that in a very clear category for all of us to see. So I'm already sharing my screen, and then I can just pull up. All right, so this is in broad sense. This is machine learning. As you can see, we have what is it on top here. Let me put it in the presentation mode. Now, if you are going to engage in machine learning, I am taking time to explain these things because it's one of the things that we actually get stuck. It's not a course. It's not me getting to our environment and start putting the codes there and then you are getting the results. No, that one you may just be copying things and pasting and running. You won't know what they are. So, but if you're able to get these distinctions right, then you are good to go. Now, already we've looked at machine learning in broad sense, that we put it into supervised learning, unsupervised learning, and then reinforced learning. Now, look at the whole of this column in a different shade. Now, under supervised learning, there are some algorithms that are supposed to be used there, and they have their subtypes. Under unsupervised learning, the same. And then when it comes to reinforcement, we only have different types, but we don't have a specific, algorithm that is meant for reinforced learning. Because I've already explained that for reinforced learning, it's like you are allowing the machine to learn on the job. So it can either be supervised or unsupervised, but the machine is learning on the job. And then I will come and explain that. Now, when we come to supervised learning, we are looking what are the algorithms that are supposed to be used here. The algorithms include regression, decision tree, random forest, and of course, classification. Okay? So these are the algorithms which are supposed to be used under supervised learning. So if you have your data points and the data fit into into a supervised learning, then you should know that these are the four categories or the four algorithms which can be used. Now, when we get to the algorithms, they have subtypes. For instance, if you are dealing with regression, and then the subtypes under this particular portion is linear regression, you can also have polynomial regression. Now, but when you come to decision tree, I have not come across the subtypes, and random forest too, I have not come across the subtype because they are actually models. They are categories of models that you need to build. Regression is also a type of model, but there are different types of them. So you have the linear regression, you have polynomial regression. But okay, let me leave it there. And then the other last one is classification. You can also use classification, and under that classification there are subtypes. So if your data fit into supervised learning, then you should check again and see whether that data fits in any of these algorithms. So, and then to be able to do that, you just look at the algorithms in broad category, then you come and look at the subtypes. Under classification, you have the k nearest neighbor, and then you have the logistics regression. So you can see that even though we have regression, but the regression is categorized. So you have the linear regression and polynomial regression all coming here. I will come and explain why they are here, and then logistic regression is not there. Then you also have k nearest neighbor, logistic regression, trees, etc., the naive Bayes, and then the SVM. So if you look at all these subcategories, they all come under classification. So what that means is that if your machine learning falls under supervised learning, and then at the same time, if it is supervised learning, you have to consider other things before you will know the exact algorithm to use. Now, when we get to unsupervised learning, you see that we have the algorithms are only three. You can use clustering, you can use association analysis, and you can use hidden Markov model. Now, under the clustering, we have subtype SVD, PCA. PCA is a principal component analysis, and then the K-means. So the K-means, what is it? I will demonstrate all these things in RStudio. for us to see. So you will see that when you are doing, if your data falls under unsupervised learning, then you should know that these are the algorithms which are applicable under unsupervised learning, and under that there are subtypes. So if your data fit into unsupervised learning and you have to do some clustering, you should know that the subtypes under clustering, it can either be SVD, it can be PCA, or it can be K-means. Now, if it falls under unsupervised learning and you are supposed to do an association analysis, then the subcategory under that will be a priori, and then the FP group. Then if it is a hidden Markov model, there are no subtypes. You can just go straight with that one. And that is under the unsupervised learning. Now, when we go to reinforced learning, we only have types. We have negative reinforced learning, we have positive reinforced learning, we have extinction, and we have punishment. Now, it is the same thing both in, or it's the same thing that is running throughout. Now, but when we look at the whole of this, whether you are dealing with a supervised learning with all these algorithms, or unsupervised learning under all these algorithms, or reinforced learning of all these algorithms, come and check something here. You can look at all the text in green. They all run through all the way up to the last type. So if the data falls under supervised learning, what kind of data will you apply when you are using regression, if you are using decision tree, or you are using random forest? The data has to be a continuous data. Okay? Even though the data falls under supervised learning, which means the data has some kind of labels, and the label, they have a dependent variable like I defined yesterday. But if at all it has a dependent variable, it has, and you are going to use regression, and you are going to use a decision tree or a random forest, then you should know that the data should be a continuous data. If not, you are not supposed to use that. Now, when you also come to unsupervised learning, you can have clustering, you can have association analysis. All the two of them, whether PCA, K-means, a priori, or FP group, they all come under unsupervised learning. But the kind of data that you can apply here should be a continuous data. In that case, all the data points are independent. Okay? They are independent, they don't have a dependent variable. But at the same time, it should be a continuous data. Now, when you come down here, classification comes under supervised learning with all this K nearest neighbor, KNN, logistic regression, and then trees, naive, and then SVM. All of them, even though they come under supervised learning, the only time you apply these algorithms is when the data is categorical. Now, under unsupervised learning, the only time you use hidden Markov model is when the data is categorical. All right. So these are the differences. When we get these differences clear, then it becomes easy for us to be able to understand the rest of the work. So now, if I pick any data and I realize that, first of all, I'll be looking at one or two things. One, can this data is this supposed to be used under supervised learning, or is supposed to be used under unsupervised learning? If it is a supervised learning, I will be checking the next time. If the data is continuous data, I will know that under supervised learning, these are the algorithms that fit the continuous data: regression, decision tree, random forest. If it is regression, you might want to be looking at whether it is a linear regression, it is polynomial regression. Now, if it is on the other side, the data is categorical, and then it falls under supervised learning, then it means you can only be dealing with classifications. And that is where you have K nearest neighbor, logistic regression, trees, and then SVM. Now, the same way, you also come here and also check to know whether it is continuous or it is categorical. Now, when it comes to reinforced learning, that one, it is the same thing. The only thing, like I'm saying, in reinforced learning is like you learn on the data. Whether you are doing supervised learning or unsupervised learning, all that you are doing in reinforced learning, you are doing is that the model has been trained to accept any other variable which might have not been considered but fit the features, so you just add it. So it's like when in real sense, when you are attending a function, then you go there, they type your name, and they notice that no, your name was not loaded, then they have to add your name to it. That's reinforced learning. So it means that the data was not part of it, but the machine learned on the data. Okay, this person did not have the characteristics, so it will tell you that what the name not found. So what do you do? But in that case, you see that those models will ask you a question. Will you want to add the person to? So you go and click yes. Then other questions will come. Then in that case, that's reinforced learning. So the next time that person comes, the name will not pop up as not being found. And that's what reinforced learning is all about. For that one, we have negative reinforcement. And in that case, you notice that the person is not around or the data is not part of it. So you might know that that one is not part. Then we also have positive. We have extinction, where there's also a punishment, and then whatsoever. These are self-explanatory. So this is how machine learning is generally categorized or actually been put. I decided to put this beautiful chart for us to see. Now, come to look at something here. There are differences between categorical and quantitative data. You know, this one I just wanted to add it for us to be able to make sense. So if you look at this is definition and this is example. I just snipped this from somebody's site. So what we have here is that when you are looking at definition, you can define categorical or qualitative data as a data that take on names or labels. You see, that kind of data, we just spoke about continuous and categorical data. So when you're talking about categorical data, these are data that is collected not by measurement. There's no measurement in it. Okay, and so what it takes is names and labels. For instance, marital status. So the person married, single, divorced, separated. These are not things that you need to measure. They are names. So when you hear separated, it means they are not divorced, but they are not together. But when you see divorce, it means they are no longer married. If they are saying married, it means they are staying together. And then, so they are names, like descriptions, like smoking status, like the serious smoker, a serious smoker, a medium smoker, and whatsoever. Eye color, you can have brown, you can have blue eyes, you can have yellow eyes, whatsoever. But you do not have a measurement. It's just a name, the name that describes the data. You can have level of education, let's say primary, secondary education, higher education, and whatsoever. When you come to quantitative data, this is a kind of data that has measurement on it. The only way you collect that data is by putting some kind of measurement. There's a scale attached to it, like height. Unless you use a tape measure, you'll be able to know the height of someone. Population size, so you have to measure it. So what is the size of the population? It has to be measured. Then the square foot, it has to be measured. Class size, so it has to be measured. Okay, so and the measurement here is by, let's say, counting. So there is a way of like doing the measurement. You can count it to get the measurement and then whatsoever. But when we move out from there, you can see this is the general description. So under the quantitative data, we have the discrete and we have the continuous. The ones that you have to measure to be able to get that data point is a continuous data. The one that you only need to count to get the data is what we call the discrete data. So when you come to the next one, you have your data, and then we categorize it into qualitative. It's the same thing as categorical, and we have quantitative, like we have it on top here. But under quantitative, we also have discrete data and then continuous data. So under the discrete, you can only get those data points by counting. You see, so let's say 5 kids. The only way you can do that is by 1, 2, 3, 4, 5. So there are 5 kids. Like 96 workers, you can only count. So discrete data is also like count data. All right. And then 3 laptops, you only count. If you don't count, you will know that there are 3. Continuous data, you only pick that data by measurement. But the two of them come under quantitative data. So by measurement, you have like 3.25 kilogram. So in that case, you are measuring. You see, if you don't measure, how will you know? So there's a scale, and then for you to be able to determine that. So these are the categories of data. So if I come here Now let me now put it in general category. So if I come here and I see a discrete data or a continuous, if I see a continuous data, then I will know definitely that this kind of data, I can only use it, what is it? If the data is labeled, if it is labeled, it means I can use it under supervised learning. But under supervised learning, I can only use it under what? We can only use it under classification. You get it? Now, if it is a categorical data and there are labels and it has a dependent variable, I can only use it in supervised learning. But in that case, because it is qualitative, I can only use regression, I can use trees, I can use random forest. And I can use under regression, I can use something like linear regression and polynomial regression. That's the category that will take qualitative data or categorical data. Now, if I go to the other side and unsupervised learning, it means that even though it is a categorical data or qualitative data, but we don't have a dependent variable there. So because of that, we can only use unsupervised learning to be able to analyze that kind of data. And then if it is unsupervised learning, it means that all the data points are independent. You don't have a dependent variable. But because it is a discrete or categorical data, when you get to unsupervised learning, the algorithm you will have to use there will just be what we have here, clustering and association analysis. That's what I was talking about. So you will have clustering and you will have your association analysis there. And so under the clustering, you can have your principal component analysis. I even have this on my PC, which I am going to demonstrate. In any case, all of this, I'll be demonstrating them for us to see. And so if you understand these two slides, I'm not going to waste much time on you again on this. So the next time we meet, I will be talking about, now that we understand the data differences, we can always just go, have some kind of data, or we can even simulate our own data and know how are we going to be able to input that data, or how are we going to analyze it using machine learning. And then why I have put up all this effort is to just make sure that immediately you see your data, you should know the kind of algorithm you are going to use right away. Once the data is labeled and there is a dependent variable, you should know that you are going to deal with what? Supervised learning. And then once it is labeled and it is having a dependent variable, and then it is a categorical data or a discrete data, I know that I am going to use either regression, I am going to use decision, or random forest. Under regression, I am going to use linear or polynomial. Once the data has no dependent variable, all of them are independent, I know that I am dealing with unsupervised learning. Once it is categorical, I know that I am dealing with unsupervised learning, and the algorithms applicable there is clustering and then, of course, association analysis. If I know that the data has been labeled, there's a dependent variable, and then the data is continuous, I know that I am going to use supervised learning. But in that case, because it is continuous, I will definitely have to use classification. So I'll be looking at k-nearest neighbors, logistic regression, naive Bayes, and then SVM. Once it is all the variables are independent, and then they are continuous, I know that I am going to use unsupervised learning, and in that case, I am using Markov model. This is very simple, very, very simple. Reinforced learning, when we are getting to artificial neural network, that's where we will see how we can apply this part of That's why this time I'm not going there. But I hope this explains, or this gives us a clear understanding of how to be able to categorize our data and how to be able to know which kind of algorithm to use. Mostly it's very important like this, because if you don't do this and then you try to put wrong data in a different algorithm, all of them will work all right, but the results will come and then the interpretation will be a problem, because you're not supposed to do association analysis and then you are doing what is associated to the other. That's going to be a problem. You see, association, you only do association analysis if all the variables do not have any dependence. None is dependent on the other. So you only want to find co-occurrence, and then in that case you are doing association analysis. So if somebody is coming to you realize that anytime somebody is coming to buy milk, the person rides a bicycle. It doesn't. The bicycle riding does not depend on buying the milk, or the milk buying doesn't depend on the riding of the bicycle. But there is a co-occurrence that at any point at all he wants to buy milk, he has to ride a bicycle. So you can check that association. Okay. So whether this is associated to this, and this is done a lot in bioinformatics. For instance, you want to find out whether some biological markers are associated to a phenotype, to a disease. For instance, I could pick somebody's genetic information or DNA. I sequence it. I'm trying to look for some biological markers, and I want to find out whether this particular biological markers co-occur or with some kind of phenotype or with some kind of disease. And when I find that there's an association between that biological marker and then the disease in that particular person, then it's enough for me to confirm that, well, that particular biological marker is responsible for the disease onset. So that's what independent variable. That's how we analyze independent variable. You can also do clustering. The clustering means those that are quite similar, you see. But for dependent variable, you always want to know whether the dependent variable is being explained by the independent variables, and then that's what we are talking about. Like yield in the farm, you know that yield depend on what? The factors of production, like the land, the fertilizer, the weeding, and whatsoever. If you put all that together, then you may want to find out whether if you have your maize farm and then the yield is, let's say, high, or the yield is this and this, and you want to find out whether there is the yield is dependent on the other factors of production. So the other factors will be independent, the yield is a dependent variable. In that case, you'll be looking at a supervised learning. And I think this is just a very clear way of explaining this for us to get the difference. And I'm sure after this night, almost all of us will be able to know what that means. So if I come to our studio like this, as you can see, I've already got quite a number of the models that I have generated. But I really want us to get to understand every single part of this thing called machine learning. And that's why I'm taking my time bit by bit to make sure that we get it. And these are the nitty-gritties of the things that we skip. Mostly, if you want to understand this machine learning and IT stuff, don't be in a hurry to jump to go and then look for codes and come and run all these codes that are here. When you run them, they will all run all right. But that's where you get, and then you don't know that kind of analysis you are doing. It's like you're just walking through bush, you don't know where you are going. No. When you understand the basics, like I'm talking about, then when you get to the interpretation, it's very easy. So if it is regression, definitely you are going to calculate something we call the RMSE. That's maybe you are trying to look at the root mean square error, and then the larger the root, what is the RMSE, then you know what that means. If it is classification, you might be looking for, let's say, confusion matrix, where you can use the leading diagonal divided by the sum of the entire confusion matrix variables to get to be able to know whether the model is good or it is bad. If the model is around 80%, has 80% prediction accuracy, then you will know that is a good model, and in that order. So if you don't know these things, at the end, what are you analyzing? You even know where you are starting your analysis and where you are ending, and that's why I'm doing this. I hope you've learned something. So from tomorrow, I'm going to start doing the main analysis, and immediately I bring the data set. If I bring the data set, then nobody's going to have a problem. So for instance, if I come here and I say, okay, let's look at the head of okay, I need to library ggplot. Okay, and so if I come and I say, let's have a look at this data set like I showed yesterday. So we are just looking at the first 10 lines. So we can see that we are looking at diamond. And you know diamond, a lot of ladies like it. They use it for their engagement rings or wedding whatsoever. But we buy it at some price. So the price becomes a dependent variable. So once you see a dependent variable there, and the rest are independent variables, then it means we are trying to look at, I mean, why, what is it? Maybe the price can be explained by the quality, by the cut, by the color, and whatsoever. So once you have one variable being explained by the others, then that particular variable becomes a dependent variable. And once you have a dependent variable in your data set that you want to analyze how that dependent variable is explained by the independent variables, then you are doing a supervised learning under machine learning. Okay. Now, if we should have a look at the other variable that I showed us yesterday, and that was the head of the iris, then if I pull it up like this, then you notice that there's no variable here that depend on the other. You see? So all of them are independent variables. But now when we come here, if we look at the whole of this, even though it is when we come here to look at it, even though they are we have a dependent variable there, an independent variable there, so we can say that is under supervised learning. But under supervised learning, what kind of data points are we dealing with? Are they continuous data or they are categorical? You can see that we have categorical somewhere, and then we also have continuous somewhere. But you will have to now depend on the dependent variable that you want to see. You can see that the dependent variable is actually a quantitative data. Of course, what is the price here? Like, it's kind of a continuous variable. Okay, so in that case, we can only maybe rely on classification. And because we are going to use classification, we might be looking at this part. Check something. So it will be classification. And then for that matter, we might be looking for we should be able to use this kind of analysis over there. Oh, sorry. No, it is continuous. So we'll be looking at regression. So because it is a continuous variable, we can look at regression. We can use regression analysis on it. Now, if it were categorical, then we'll be looking at classification. And that is why I was saying that this table is very important, and then keep it at the back of your mind. So if we go back to if I go back to RStudio at the moment, so you notice that here we have the data set. It will definitely fall under supervised learning, but at that we look at the data point and they are continuous. Once they are continuous, then obviously we are looking at all the data points that come under continuous, under supervised learning, all the algorithms. So you are looking at regression, decision tree, whatsoever. If they were categorical, we would have been looking at classifications. Okay, and then because we are looking at regression, at the end, what are we calculating? We are calculating the root mean square error, and that will be what is going to determine, that's going to give us our final answer. If we were classification, we'll be looking at confusion matrix, last, and we are able to get our confusion matrix, then we are good to go. Now when we come here, all the data variables are independent. So because they are independent, then it means that they will come under unsupervised learning. But at the same time, if they are independent, are they categorical or they are continuous? 5 point something, 5, they are what? You can see that it's actually a continuous data. Okay, apart from only this particular column, the rest are continuous data. So what kind of analysis can be done here? Now let's get to this place. Because it is continuous, then we can do clustering there, and then under clustering we can use k-means, and I actually used that yesterday to be able to do that. If I go back to RStudio, I can show you. I've already analyzed that. So you can see that here I used this place. That was the k-means that we were able to use to do the classification here, and then it was there. But I'm not going to run that today. I'm going to do that tomorrow, and in a separate video where I'm going to do 2 models or 3 or 4 models for us to do the comparison and see how it works. So far, that has been the video of today, and I hope you have been able to get it quite clear. All these things that has to do with supervised, unsupervised. Of course, you will have the next time you have your data, you know what you are supposed to use the data for, and you know the algorithm to apply. Thanks, and then have a great time. Bye bye.